Hey everybody, coming to you today to show you a little update on the DM3000 lathe conversion. Picked this up, probably about 6 months ago now. Trying to think of where these cards go. I believe the card's gonna be up to my left. I'm gonna throw a card up here to another video that I did with some of the stuff I'm working on this lathe. She finally runs. It's been a ongoing project, kind of a side project, like not really working on it real hard. Around Christmas time I decided, you know what, I'm gonna kind of get this thing running and go gung-ho on it. And a good thing, because the computer on the Sakai lathe died today, so it's perfect timing. I got this one running. It's going to be a much sturdier lathe and be able to punch out knobs and stuff a whole lot faster. So I'm going to start with kind of some things I did to it. I was trying to do this on the cheap. I'll be honest. I was trying to keep it cheap. Picked the thing up for 300 bucks. I sold about $300 in parts off of it. I've probably dumped about 400, maybe 500 into it. So that's about all I have into it now. It's about 400 or 500 bucks. I did a Mach 3 conversion. The thing ran when I got it. I put it in the little computer. I could make it run. So I knew the motors and stuff were good, but they were weak. They were old. They're 1980 steppers. I don't say the new ones are technologically like advanced, but they're more torque for their size, which was good. So I used the same size steppers. My original plan was to just swap them out. They were gear driven. They had metal gears on the end of the stepper motors that were then running a plastic gear. Shouldn't have wasted my time on that. It took a lot of time to turn out the centers of those spur gears on the motors, put them in there, and turned out the plastic gears were getting brittle, and within a few times of running it back and forth, I'd pop teeth on both of them. So I ended up having to do a belt drive conversion on both the X and Z axes. You can't really see in here, but inside of here, behind that fan, is a aluminum bracket I made and put a NEMA 34 with a belt drive. I believe I'm 30 tooth on the motor and 40 on the lead screw, if I remember right. Got the backlash down to 5 thou. I wanted to get down more, but I used the backlash feature in Mach 3, and it seems to be working pretty well. I've only played around, turned a couple parts. I haven't actually ran a program. I've just done it manually. Literally today I made this much progress. Also going on down here in this end, it's tucked down in here, but I have a little relay board with 4 relays, using one of those on the oiler system. This automatic oiler used to run whenever the machine was on, and especially with working on it, I've had it on a lot. So I was watching a guy online here, Kelvin. I'll throw a card up to his videos, 1 to 10 CNC, and he did a conversion similar to this for a lot more money. He spent a whole lot more money on his conversion, but that was one of the things he recommended, and good recommendation. So I moved that to a button on the front. Now you hit the button, it fires the relay. It's a little 12-volt relay board, and that relay kicks in and gives you 110 to the oiler. And then the other thing I did on this end is, you can see this giant bolt head here. I have an ER40 collet holder on the spindle that I'll show you in a minute. And I turned the outside diameter of the bolt down. I cut it off, turned it down, bored out the center, threaded it, and then that's on a double-ended shaft with 1/2-inch 13 threads that fit in the ER collet holder. And then I just tighten it down so it holds the collet holder in real solid. I don't know that that's going to be the ideal way to hold my parts. That's what I've been using on the Sakai. I already had the collets. So it's kind of a cheap way to go, and it works. I'd love to get a pneumatic collet closer. Dynamite actually sold one of those back in the day. I watch eBay. If one comes up, I'm going to try to get my hands on it. Although I don't know what the maximum diameter that collet closer held. So I may or may not actually end up doing that in the end. You can see this end's got a bunch of holes in it. There was a shelf on it when I got it that the guy had these giant controller boxes on it. Got rid of that. I had to put a new hinge on the door. It was missing a hinge. And this hole is where the pneumatic collet closer would come through. That was a hole, so I made a plate and bolted it on. And I do a little repair on the latch. Now it latches up. So I'm going to go ahead and do a cut, move the camera around, and I'll show you the front side of the machine and what we got going on over there. Alright, so here we are around the front side of the lathe, the business end that you're going to be used to seeing. Did a few things over on this side. So the machine itself is in good shape, as far as the castings, pretty heavy casting. You can't see it in here, but it was on an angle iron table that we shortened the legs and put on casters to be able to move that around a little bit more. The ways were all good, the lead screws were all good, all that was in good shape. Built this little sheet metal cover here, which is over the X-axis stepper motor. So underneath there is a, trying to remember what NEMA size is. It's a smaller stepper than what's on the Z-axis. We got that under there, got a belt drive on that as well. I tried to be cute and make it really small, so it's only got like a 6-inch belt, so it's a really snug little package in there, but it's in the existing, or that was where the factory location for their stepper. Again, that was a gear drive, this is a belt drive, but it seems to work pretty well. Seems to have plenty of power, so I'm real happy with that. Up top here is the stepper motor and solenoid for the 6-position tool changer. I don't actually use the solenoid. There's some code out there. I'll throw a link below to where the message board is where I found that code. There's code for a macro to do the tool change. Took a little playing around to get that to work, but it's awesome. Really digging the tool changer. It's one of the big features about this that I really liked. I had a quick change tool post on the Sakai, and I like the turret on this. It'll be real nice to do repetitive parts one after another, and the rigidity of this thing is just incredible compared to the little mini lathe. Let's see, so I did replace the stepper in there. I didn't really need to, but it was a small one, it was cheap. I think I paid like 40 bucks for that stepper. While I was doing it was the time. And that was just a bolt in. I was able to bolt the mechanism back on, so that was super simple. I was, a no-brainer I think to do. I'm trying to think what else on this end I got. I'm going to spin around and show you from the other side. So this has a door on it that I'll be using probably when I machine. I don't really know that I'm going to do full flood on this. I've been really liking the oil spray with air, kind of the fog buster style. I have a DIY one on the KX3 mill, and I will probably do another one on here. I actually have one that I had on an old hard hinge lathe, so I'll probably just swap that over onto here, at least initially. But the door will still be nice. It's kind of weird that almost none of these Dynamites had any kind of a cover on this end. Kind of strange. I may build one, we'll see. It's kind of neat that it's got this fluorescent light in the back. I converted it to an LED. I just did a direct swap in LED. It's plastic housing that way. I need to build a little shield for it because just playing around cutting a little plastic today, it was flung up on there. So I got to do something about that. Switches up top are all still intact. Not many of them do much anymore. The emergency stop is actually wired in line with the emergency stop down here that I actually use. Here's the emergency stop that I use. And then here's the button for the oiler system. You see it turns on blue. And then this one here is wired up to a relay also, but I'm not actually using that relay for anything yet. That may go on a solenoid for the air spray oil mister system. May go for the light. I'm not sure what I'm going to use that for. Right now, I have spindle control through a relay only off my breakout board. I'm not controlling speed at all. The speed is still controlled with the knob up top. Right now I'm just using the factory driver board for that. It's got a servo spindle motor on here. Eventually I'll probably swap over to a newer driver, but it's going to cost me a couple $100 to do it, and this one works. So I'm used to just being fixed speed from over on the mini lathe, so I'm still going to run the fixed speed over here, and I can vary the speed. I can reach up with something and turn that knob up top. The local speed control, the second one on the bottom on the right. The bar feeder never did anything. Coolant's not hooked up to anything. Program local. If you turned it to a program, you could run the little computer box thing. I'm selling that on eBay. I don't have a use for it. little switch up at the top, up at the very top right, that lets you know whether the door's open or closed. And from the factory, you can set that up basically like another emergency stop switch. So if the door opened, it shut off. I've actually bypassed that. I don't really know that I'll use that. You can see, yeah, you can see that in the video. This is the ER40 collet holder. Like I say, I was used to that from the little lathe. The one problem on here, the spindle motor has a brake. Turns out the brake doesn't hold enough. It held enough that I couldn't turn the spindle by hand, but it didn't hold enough to actually, you know, tighten and loosen the neck on the collet. So I built this little guy. There's a little aluminum bracket here and then a little piece of steel. There's little grooves in the back of the spindle, and so this little arm has a little catcher on the end that I just ground in there. I already know that I need to zoom in. It's nothing real exciting, but I just tip that up, pop it in one of the holes, and then I can reach in with a wrench, pop it loose, pull out my part, tighten it back up when I put in the new part. Like I say, it's not the ideal thing, but it works. It works for what I'm doing. I'm going to do a bunch of the back sides of knobs, then I'll pop out that collet, switch to a different collet that's smaller to do the front sides of the knobs. Not a real big deal. It'll work. Yeah, the back's still a little bit ugly right now with wiring. I don't have everything really lined up clean. I've got 3 stepper motor boxes. Again, they're in the video that I threw a card up to earlier. I showed them in a previous video. Those are working just fine. A little breakout board off of Amazon. I think it's a Sane Smart that I'm using. It's like $10, $15 breakout board, just a cheapy little breakout board, but it works. And yeah, so that's pretty much it. I'll fire it up here and just give you a quick run through of how it works. Probably gonna change out the fans, and it's got a couple old computer fans. I think I mentioned in the previous video, this thing came out of a company out here in Colorado called Coors Tech. It's owned by one of the Coors family, like the Coors Brewing family. They make ceramics, and their machines that come out of there are all caked in ceramic dust. They run some covers. You can see all these screws along here. We use those to plug holes. They do like a full apron over all the ways in that to keep things a little cleaner, but gobs of ceramic dust keep falling out of this thing. I have cleaned it and cleaned it and cleaned it, and they just keep coming. I'm finding them everywhere, which is kind of a pain in the ass, but it's getting cleaned up. It's finally getting to where they're not just goopy everywhere. So that was a little oddity about it. Just had to clean all that up. That's just, it's the fans. So the fans are really loud on it. So when I fire it up here, it's gonna be kind of loud. I'll try to talk over the noise, but I just use the emergency kill switch here on the front for my power. I already have the light turned on. The light switch up top works. I just leave the light on whenever I turn it on. You can hear those fans are running. The Mach 3, I'm running a screen set off of their website sorry, I'm trying to get rid of the, there we go. It's one of the ones you can download off their website. I like the screen set, I like the look of it, but it doesn't have soft limits, so I've got to go in and do a little editing on it and add soft limits in there. The machine has limit stops, limit switches. I have the one in Z hooked up. The one in X doesn't seem to be working. I haven't really messed around with it. If I can just set up soft limits, quite honestly, I'll probably just set up soft limits and always park at the same place when I shut it down. I have a piece of aluminum in there right now that I was just playing around with a little bit earlier. I'm actually probably not going to go ahead and turn anything while I'm talking this time. I'll do another video actually turning something later. Just because I'm still playing around with it, with speeds, feeds, depth of cut and all that. And I don't want to think that much. It's like 8 o'clock at night and I don't really want to think about it. So I'm just going to give you a quick little run through of how she runs. I'm going to do some rapids. I just turn off the reset. So we'll go to Z first. Oops, that wasn't rapid. There we go. That's rapid speed. It stalls out if I start going much faster than that. It's It's not super fast, but it's reasonable. And then here's X. And I'll go ahead and do a tool change, because like I said, this is one of the coolest parts about it. There's 6 turret positions. There's one holder here for round stuff, and it's got a 1/2-inch collet. I just happen to have this Jacob's chuck with a 1/2-inch shaft, so that's what went in there for now. I'm gonna machine another one of these and put a ER16 or an ER20 collet holder in that for one of the other positions, so I can put a boring bar in there or different size drill bits and stuff. This is the 1/4 inch that I use to drill out the knobs. I just already got that mounted up. And then I have 3 of the holders, they're a little like angled clamp for cutting tools. It came with a bunch of cutting tools. I say a bunch, it came with a bunch of inserts. It came with, I think, 4 holders. I have 3 of them in right now. I'll probably play around with those and maybe swap some of those out, but I just mounted up the 3 that I thought I might use for now. And yeah, so the tool change macro, you replace the M6 start in the macro section. One thing that I struggled with was getting the syntax right for a tool change. In Mach 3, a tool change command in the turning side is M6 for turn, then T, and then your tool number, which can be single digit or double digit. So I do 01, 02, 03, all the way up to 06. And then the next 2 numbers are your offset. I'm not sure if that's from where you're at. I don't know if that's absolute or relative. I actually haven't played around with that enough to know. So, like right now, I have tool 3 called, and I'm going to switch. I'm going to go to tool. Let's see. We'll go to tool 6, which is this drill bit. So it's going to go, 1/2 a revolution. Now this macro, we don't use the solenoid. The solenoid controls a little pawl that pulls up and down. So if you turn it clockwise, it'll turn and just kind of snap past that pawl. And then this macro setup that you turn just past it, then you back onto it, so it's a rigid system again. And that puts you locked into your position. So if you want to go from tool 1 to 2, that's easy. That's 1 click. If you want to go from 2 to 1, then it's click, 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 and then back onto it. So it only will spin clockwise. So setting up your tool order, if you want to save a little bit of time, you set it up in an order that is the order you'll actually use the tools. Now, if you use tool 1, then tool 3, then you go back to tool 1, it's just going to take a little bit longer to wrap around. So I haven't actually tried this with the drill bit in yet, so I hope that I put in enough of a Z offset here to clear it. So I said tool 6, and I'm going to do let's see, I'm sitting at 4. I'm going to do a 5-inch offset, so it should move a little bit to the right, and then do the tool change. Gotta get my cursor over the reset, just in case this doesn't go right. And it went the wrong way. I'm going to see if that drill bit still clears. Yeah, it did. So if you heard at the end it made that little like grinding noise, that's the stepper motor stalling out. And that's the way everybody's running this. I've seen other videos online. That's the way people are running it. It seems to work. You just barely fight back against the call. So it doesn't seem to wear out any of the equipment. So I don't think it's too hard on there. I actually have the amperage turned down pretty far on that particular stepper. It's really easy to turn it clockwise. So I just had the actual stepper driver box set to one of the lower amperages that it'll run. We'll do one more and I won't talk through so you can actually hear it in action. So yeah, there you have it. That's the Dynamite in its current phase. The next video with this guy, I'm just going to turn this a little bit so you can see that turret a little bit better. I'll do one more tool change too, because to me that's one of the coolest parts about this this lathe is that turret. It's one of the main features that I wanted. So there you're looking at the end. I'm going to call up tool 3. So there you go. That's the dynamite in action. Like I say, the next video I'll shoot with this will probably be actually turning a knob. So you can see how the billet aluminum knobs that we saw at Cripple Concepts are cut. So thanks for watching. I apologize this video got a little bit long, but I hope that it gives you a little more information on what I did and what some of the other guys that have these lathes do. They come up for sale from time to time at auction, and if you're willing to put a little bit of time and elbow grease into them, they seem to be a pretty stout lathe for at least the money I have into it. I'm gonna have well under $1,000 into this lathe, and that's, I mean, that's just so cheap for what I'm getting out of it. And who doesn't love that wonderful 80s looking arcade decal? That's the factory decal. That thing's just too sweet to ever take off. It screams vintage lathe, vintage 1980s. So anyway, thanks for watching, and we'll see you next time.